Hey, welcome to day 52 of 100 Days of Code in IoT Challenge and part 6 of Game Snake development on a microcontroller. I'm Thomas and this is the channel that educates you on IoT and web development by showing how to build projects step by step. Today, I'm gonna continue working on a food system. So basically food appearing on the screen and making Snake longer when it eats it. I've already explained yesterday how this is gonna work visually. And today I'm just gonna carry on implementation. So let's start by switching back to the code. Okay, so I've got Visual Studio Code opened here with a Snake game project. And let me just quickly remind you what is going on here in terms of functionality, right? So here we've got everything up to part 4, right? So in terms of functionality, this is Snake appearing on the screen, moving, buttons controlling the direction of the movement, and we also have the collision check, right? So if we hit the end of the screen, the wall, or Snake hits itself, the game is over and we just display game over text on the screen, ESP restarts and we start the game again. So that's what's happening. That was up to part 4. And from yesterday, I've added some extra functionality which is not completed yet. And that's what I'm gonna focus on today to complete everything. Let me tell you what it is. So first of all, we've got a new functionality that adds a foot at the beginning, right? So at the beginning, we take 2 random numbers for the coordinates, and in the memory, in this field 2-dimensional array, we add a field element, which is, by the way, also something new, right? And that field element has a pixel and that pixel type is foot, right? So that's also new. And I'm gonna just talk about this as well. But let me show you. You remember probably this enum called pixel, and I added a new type of that pixel, which is foot, and that's something we show up on the screen. And actually, if you run this code now, you should see, thanks to this method call where we pass the function that draws the pixels for everything that is not empty, we should actually see the game field with the wall around, with the snake, and this small pixel of foot somewhere in the random location on the screen. Second thing, that I have added is the field element, right? The field 2-dimensional array used to be a byte type, right? So that was uint8_t. Now it's a field element, but that field element struct still takes just 1 byte of the memory thanks to the bit fields that I'm using here, right? I'm using them because pixel, I allocated 4 bits for the pixel which state uint8_t, a byte type, but we don't really need whole 256 numbers, we just need 7, right? Because this is our pixel. And this additional flag that we have, which is hasFoot, that is gonna allow us to calculate the moment when the snake length should increase, right? I also explained it visually yesterday. So if you haven't watched that video and you are still interested in the details how this is going to work, I really recommend to watch previous video. Okay, so that's it in terms of explanation, in terms of reminding you what this code does so far. And now what we can do is to go back to the moment where I finished yesterday, and that was on the verification if the functionalities like snake moving on the screen, like a possibility to change its direction, and the collision check are still in place. So let me switch to that moment right now. Okay, it is still working, but we don't have the logic to eat the food, right? At the moment, if you try to go and eat the food, then it's gonna be like you hit the wall, right? It's gonna be game over. So we need to implement that behavior as well. Okay, so yeah, let me quickly go back to this one to the spreadsheet and explain again, right? So we have a head in here, and let's say the food is right in here. So what's going to happen is we change that to left again, right? So that stays the same, right? This is the part of the logic already implemented, which is in here. So we've got move head. We calculate the next field, right? That's gonna give us the next location, right, of the field element that the snake is gonna move to. We have a collision check, right? And for the collision check, there's gonna be the first change if you think about it. But yeah, actually we have to do it now because like with the current code, food is not empty, right? If it's not empty, it's over true. The game shouldn't be over when the food is the next one. So what is going to happen in here? Simplest way for now is gonna be if it's different than empty and it's different than pixel food, right? If it's food, that's fine. It's not a collision. It's not the collision. And yeah, by the way, I can extract this method as well to a separate method. Sorry, I can extract this bit of code to separate method, and instead of having a comment here, have a private method called collision check. And I will do it, but not now to not confuse anything, right? So yeah, so that is handled, right? So now the food is not treated as a danger, right? It's not game over if you go on the food. And here we've got the actual logic that changes. First of all, it changes the actual head, right? So that was something like here. It was head before. This particular line is changing this to L, isn't it? And now the next line, as you can see, changes the new location. The next one, the next segment, that's gonna be new head. It changes this to head, but because we have a food there, we want to change it to head, but with the true, right? We would like to pass a true as the has food. So we're gonna have to detect that somehow. And what I can do is something like this, I guess, in here. So as a second argument, I can just pass field new x and new y equals, and that is gonna be pixel food, right? So remember, this really first is going to be evaluated before that assignment, right? So what's gonna happen? We're creating a new field element with the pixel head, and the second value, which is has food, is the result of that comparison, right? And that comparison is checking if the field that we are about to change, we swap with the new field element pixel head, is the food. And if it's the food, that statement, right? This expression is going to return true. Otherwise, it's gonna be false. So we will have a head either with if there is no food, it's just gonna be base head, or we will have something like a head that is green. It's something like that, right? So head with extra bit of information that tells us there was a food eaten at this point. Okay, so that's what happened, right? So that is how you handle the head. But now I need to go back to this line, and I'm gonna show you why, but let's move the snake now, okay? So we're going to move the snake because this head stepped in here. The tail needs to get removed, right? So we have 1, 2, 3, 4, 5, 6, 7. It stays 7. And now the head is going to move again. So what's gonna happen in here? We change the actual head to left, right direction. We keep the direction as left. And this line is executed. And now this line is executed, but what is created at the moment is the P, which is the direction, the pixel, sorry, this is the pixel mapped from the direction. So that can be up, down, left, or right. But the has food information is lost, if we keep this line like that. We still need to get that information. And to do that, I need to check if the actual field, this actual field, right, that we're changing, the actual head, this is a head. This point, it's still a head, right? But after this line, that's not gonna be head anymore, but the relative direction to the previous segment, which is gonna be our new head that is assigned in here. And what I want to check is if the actual one has foot. Because if it has foot, we would like the new field element, which is not a head anymore, but now it's a pixel sort of direction, right? It's up, right, down, or left. And we would like to keep this information about the food being eaten there, right? The food has been eaten at this point. And now we change to the next one, and this one checks if the next one is food. And in our case, the moment we have eaten the food, generated a new food somewhere there, right? So the next place this is going to move to is gonna be in here. That is removed. Okay, food is there, so that's all covered. But in the code, that food hasn't appeared in a new place, right? It's just been eaten. So something to be added in here, right? And that is gonna be on that check, right? So if the new pixel, the pixel that we are going to move to, is the food and is gonna be eaten, right, in this step, we would like to add a new food. We already have a method to add a new food, so that's gonna be easy, but that needs to go out of here. Because what's going to happen is we still keep, like, you know, that stays essentially the same, right? I've just extracted this, I moved it to a variable. That expression I moved to a variable, but this expression result is still going to be passed to the field element. But the thing is, I need to do something like that. If has eaten this, add food. That's what I want to do, right? If the snake has just eaten the food, we need to add a new food. That is important, right? So that is gonna happen, right? Otherwise, we wouldn't see any food or anything, right? Okay. So yeah, so that logic is implemented now. Snake can eat, and also when snake moves, the place, right? The field element where the food has been eaten, right, it stays at the same position, right? So it is being digested. However, at the moment, there is still one bit of this implementation missing. Because if the snake gets so far as there, let's say, so hang on, that's gonna be, let's move it by maybe 3. So 1, 2, 3. And let's move 1, 2, 3, and 2 more, okay? So there's gonna be 1, 2, 1, 2. If we are here at the moment and snake moves again, we don't have a logic to increase the length of the snake. We don't have it yet. We need to add it. And that's what I'm going to add to a move tail, right? That's gonna be on the move tail if you think about it, because that's where it happens, right? So move tail, essentially, what needs to do is to check if at the actual location of the tail, there is a food, right, that has been eaten. And if it's there, it's not going to move the tail. The tail stays the same. So when that new tail is that tail is picked up right in here, the next iteration, the next call of the loop, because the tail stayed at the same place, that is going to just try to remove the same pixel, right? The same pixel is gonna change it to black again, but that's already been changed to black, right? So that stays the same and the snake length is going to increase. So in conclusion, what we wanna do is simply when the snake moves one position, right? In this case is to the left, we don't want to move the tail there, right? And because of moving the tail, this field is gonna get removed. We don't want to do it. We want to keep the tail at the same place, right? But we want to remove this flag that the food has been eaten. So essentially, that just requires us to have an if statement. I'm gonna put it here for now, but it should be actually before moveTail method is executed in the moveSnake. Because that should be like, you know, if you think like, you know, from the logical point of view, you don't want to move the tail if there was a food just digested, right, in the snake digestive system. So yeah, so anyway, here what's gonna happen is field tail x and tail y, if it has food, right, if it has food, what we wanna do is to do just return in here, but we also need to remember that I need to swap this one with a new field element that has the same pixel, but it doesn't have has food, right? Otherwise, we're going to have a snake increasing all the time, right? So that's not something we want to do. Okay, so yeah, so this was the second step that needs to be done. You know what? I can actually extract it to the move snake, right? So we won't really do that, right? We don't want to move tail. I think it's actually gonna be better if I just go to move snake in here, and we're gonna do the check in here, right? But yeah, we don't have a tail x and tail y, but we can get it easily by doing maybe something like this. So let's have a field element equals field, and that's gonna be snake get tail dot x and snake get tail dot y. So we will get the field element, and now based on the field element in here we can check, right? If the element has food, then we want to do something like that. We want this to equal to a new field element, but this field element this time is just still gonna have the same pixel as this field element, the previous one, but there is no food anymore, right? The default has food is false, so it's gonna be false, and we don't move the tail. So that's what's happening in here. I've just extracted that functionality out of the move tail, and we're not moving tail. That was the point of extracting this. Right. Okay, so that is all done. However, we still don't display the food on the screen. I mean, we display at the beginning. If you look at the draw snake at the moment, with the use of the field for each, we display it on the screen because that pixel is not empty, so it's going to be white on the screen. And I would like this to be green, that's one thing. So maybe I will do something like that. Then I just draw a pixel, and we're going to return to not change that pixel back to white. So we'll have green as a green apple. Nice. Okay, so that should show us the apple at the beginning, right? The food at the beginning, this small green pixel at the beginning. But yeah, there is no way to, for now, there is no code, right, that draws a new apple a new pixel, new green pixel on the screen when we add new food, right? That's not happening if you think about this. Because, add food has nothing to do with TFT. I want this to be kept separate. The game logic from the actual display, because display is separate to the game, right? Display doesn't have to know about Snake. So I was thinking, how can I approach this, right? Still show this pixel on the screen, but without having to go through every single element like here of the screen, somewhere in the loop function to check for the new apple, right, appearing on the screen. I don't want that. That would be too much instructions to the CPU, right? Too much complexity of the program. So what could be other way? Other way could be storing the coordinates of the food on the game, right? As a sort of, we could have a members, right, of the game that store the location of the actual food. Yeah, that's sort of okay. But also, I would have to constantly check for it, right, in the loop. I would have to constantly check if those coordinates have changed, and only if they've changed, I would display it on the screen, right? It's not terrible, but also not perfect solution, and maybe I pass on that. The third one that I'm thinking about, and I'm thinking about doing actually, I'm not sure if this is the right solution, the best one, but it's gonna serve us great, I think, is to use an event-driven approach. So what we can do is to pass a callback to the game that will be called whenever the food is added to the screen, right? We could do something like that, can we? And I'm going to show you how to do it. So we've got our snake in here, and we could essentially take it in the constructor. That'd be one way. And maybe that's what I will do, but will I have access to TFT screen at that point? I think I will do. So we could pass it here, and then when the food is added, right, so we have add food, we could essentially have something like, sorry, that wouldn't be here, that would be here. We could have something like on food added, and that would pass X and Y, right? Something like this. And then on the other side, I would have this function that uses TFT to do that. Yeah, I guess that might be a good solution. So yeah, so let me add a private method, private member of this class that will be std function. I think I need to include functional here first, which I should have done earlier, but I haven't. And that would be std function, that function that doesn't return anything, but it takes uint 8t, that is for x, and uint 8t, that is for y, and I can call it on, how do I call it? On food added, right? Something like that. I'm gonna change it to null pointer, set it to null pointer at the beginning. And in here, where is this add food? There it is, okay? So in here, I'm going to do a check. If on food added is not a null pointer, then we're going to call it with X and Y, right? So that allows us to be flexible about it. So I can, in the constructor, I guess I could, as a default parameter, the default argument, have, that has to be std function again. Let me copy it. on food added. So maybe that's what I will do. So that'll be on food added equals on food added. There we go. There we go. Yeah, I guess we could do something like that. And then in the game itself, where we created, this is where we created, as the second argument, I'm going to pass this function, this lambda function that takes x and y. And what it's gonna do is to do TFT draw pixel x and y and green as a green color, right? Do we have green? Yes, we do have green here. Nice. Nice, that can happen in here. I mean, I sort of duplicated that behavior now. So maybe even better, I could have this done in the one place. That should be sort of done in the one place. Oh, okay, I see. Yeah, there is a small issue with this approach. There is a small issue with this approach. Sorry about it. But yeah, I'm gonna show you what is that issue. So yeah, I can now remove the draw pixel thing. And we can essentially do that if it's a food, then we're not going to draw it. So that can stay as return. That is fine in here, right? So only if it's not empty and it's not food, maybe that's what I will do. And it's not food. Only if it's not empty and it's not food, we're going to draw a white. So that will be covered. However, this one is sort of wrong because at that point of time when the game is initialized, when the game is created, in the constructor, let me show you, add food is called. And because it is called, it's going to try it's going to try. It's not going to try. It's actually going to add that food. It's going to add that food and call on food added before the screen is even initialized, right? So that is not really gonna work. And even though it would display, it would show the pixel on the screen, right after that we initialize it because setup happens after the constructor of the game, right? There is a constructor of the game that's happening first. And then there is a setup function. And then there is a setup function. So yeah, let me quickly fix it because I don't really want to change this approach. So what I'm gonna do is to introduce another method for the game that is gonna start the game, okay? So what's going to happen is we'll have another public method, like we've got move snake is over and field for each, and that is gonna be void start. Something like start the game, okay? And the start the game is actually gonna do these operations. So that is gonna add a snake, add the wall, and add a food. So now we have a constructor simplified, right? Only assignments there. I mean, there was still assignments though. But yeah, not more logic. It's just very simple at the moment. Okay, so you are supposed to now call a start. And that's what I'm gonna do in the setup. So when the setup happens, we do game field for each. So that needs to happen after the game is started. So we do game start, field for each. And because of game start and TFT is already initialized, we should see the food first. And then right after that, we should see all of these white pixels, okay? And yeah, and I think this is pretty much it. If you think about that, that should cover the whole logic of the food. So let me try to compile this. If there is anything I might have missed, and there is, as always. So operator here is wrong. Okay, yeah, that is a simple mistake that I've done. So that should basically be, if it has eaten, that should be still as a get pixel. I have missed that. Cool. Okay, so now it compiles. And yeah, now I'm going to upload it and see if the game actually works. Because, you know, if you think about this, this is almost whole game done, right? What is missing is the point system, right? We need to have some sort of the point number on the screen, right? Or the length of the snake or something that we can keep track when we play the game and keep eating the food as a snake. But yeah, let's have a look how this works now. Okay, the code deployed. And now, as we can see, there is this small green pixel that showed up on the screen, and this is the snake food. So let's go and let's try to eat it. Let's see what happens. It's actually not that easy to eat it. Bit small. Okay, there we go. And now we can see another green pixel in a different location, right? Our snake is a bit small, so we are not able to easily tell that the length of the snake increased. So I guess I'm gonna have to speed this up a little bit, eat more apples until this is gonna be apparent that snake length increases. I think we can definitely tell now that the size increased, isn't it? And that is it for today. Thanks for watching. Tomorrow I'm gonna show you how to implement the score system, right? So you're gonna make some space at the top of the screen to show the points, the number of apples, right? The number of these food pixels eaten by the snake. If you like this video and you find the value in my content, don't forget to subscribe so you will stay up to date with my channel. Thanks again and see you tomorrow.